Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, and thank you for choosing IT Pro TV, helping you learn wherever you go. I'm your host, Zach Memis, as we continue on with CompTIA A+ 902 series. In this particular episode, we're looking at environmental impact and controls. And the person giving us the information we need is the one and the only Wes Bryan. There he is. You see him, you love him, you know.
Hey, Zach. Thanks for having me back. That's right. We are going to be talking a little bit about the environment. Well, at least some of the things that we have to worry about in computing that can impact the environment. And we'll definitely look at environmental controls, really, when it comes down to it. And there are some things that you have to be aware of. Now, we said environmental impact, right? Well, what that means, obviously, that there are things that that are inside of your computing, environment that could have a detrimental effect on the environment. Now, I will tell you that it's not only IT, if you will, here. So some of the concepts we'll see, you'll probably even see in things like, food safety, right? We talk about food safety courses. If this happened to be a food safety course, you might see some of these things here as well. If you've ever worked in a restaurant, right, you'll probably see some of the same concepts. So I want you to understand that, well, while some of these things are unique to IT, not everything is unique to IT. Some of these have a commonality across multiple countries, if you will, as well as multiple industries.
So we're not just talking about a clean room, right? We're talking about the complete environment.
Yes, we are. So that's a good starting point, right? So we're talking about things like, how do we handle different chemicals? How do we handle and dispose of different substances that might be within our environments, right? Here at IT Pro TV, right? There are times when we have to go over to our server closet, right? And we have to replace, we'll have things like battery backups, which we're going to talk a little bit more about battery backups and what they actually mean for us as far as, protecting from things like power surges, brownouts, if you will, blackouts. But what I want to look at is, well, the environmental impact of the batteries that are in battery backups. Now, you have to understand that when we talk about a battery backup type system, we're talking the potential to have 12, 20, 30, 60, 100 batteries the size of motorcycle batteries, right? Very, very heavy, especially the more of the battery backups you have, right? So when we have to replace those batteries, they have like any other battery, they have a shelf life, and their life cycle is spanned, if you will, is only going to be, so far, right? Whether it's a year, whether it's 3 years, 4 years, 5 years, at a certain point, we're going to have to replace those batteries. So when we do, how do we handle the batteries? How do we properly dispose of the batteries? But that's not the only thing, right? There are other chemicals that you have to worry about too. Right, we talked about an A+. One of the things we mentioned in our networking section is the difference between things like plenum and non-plenum grade cabling, right? Plenum grade cabling is cabling that the plastic sheathing around it, right? The protective jacket around the outside of it, when burnt, doesn't give off a toxic gas. Non-plenum is essentially polyvinyl chloride. And polyvinyl chloride, when burnt, gives off a toxic gas, and when inhaled, could cause harm to, well, not only the environment, but the people that are within that environment, right? So there are things that we have to keep in mind that we need to know about, right? And that's where something known as the MSDS comes in, the Material Data Safety Sheet, if I could remember. MSDS, right? Now, when we talk about the Material Safety Data Sheet, some of you are probably aware of this out there, that is a term that I really think that CompTIA has just kind of done a copy and paste between the exam objectives as it's gone through. God, back when I started, 501, I think, and now we're 601, 701, 801. That's right, now we're up to 901. And some of you are probably aware that it is no longer called MSDS, even though it's most commonly recognized as MSDS. In fact, when I was working in the restaurant industry, we always said, where's the MSDS, right? Well, it's now called the Safety Data Sheet, the SDS. Safety Data Sheet, make sure I get my acronym right. Yeah, it's called the SDS today. And I want you to understand that if you are studying for this exam and you go out and you look for SDS, or you look for MSDS and it keeps saying Safety Data Sheet, and you're like, what the heck is that? Well, it's because they actually updated the standards, and it's no longer called MSDS, it's called Safety Data Sheet. But
SDS.
content is going to be the same. And for the exam, I want you to know and understand a little bit about the MSDS. And again, that's what they call it on the exam. They call out exam or MSDS documentation for handling and disposal. So let's go ahead and talk about a little bit of the things that you can find inside of this material safety data sheet, MSDS, from here on out, right? The MSDS has a lot of different things, right? One of the things that it has is, well, things like, first of all, first aid measures, preventative measures, handling. How do we handle hazardous substances, right? And what I mean by that, it could be as simple as a cleaner. I remember one of the things that we used to have common to just about every different restaurant that I worked in was some kind of degreaser.
Oh, yeah.
Now, it always had these colorful names, you know, and I quite literally mean colorful names. It'd be called Green Monster in one, it'd be called Purple Tiger, and if you guys work for that company out there, I'm not trying to endorse you or steal your thunder in any way, but I believe in one it was green. It was a green substance. It was a degreaser, and it was called Green Monster, right? And then in another company, they had a degreaser, and it was called Purple Tiger, right? Well, what's the difference between them? They're both degreasers. Well, there could be a considerable difference, and that's where the MSDS comes in, right? Because a degreaser is a degreaser maybe to some, but the way you handle and you work with degreasers could be a little bit different, and you have to be aware of that, right? So MSDS can have things like product information in it, and that's important, right? And why is that important? Let's say something goes wrong. All right, God forbid something goes wrong. We want you guys to be safe out there. We have stressed that in other episodes. You guys and gals out there cannot be replaced.
Nope.
Everything you work with can be. I don't care how expensive it is. You can't be replaced. All right, so let's say the worst case scenario, something happens, and you have to call poison control, or you have to go to the hospital, right? Well, what'd you get on you? I got this purple junk on me. I got this purple stuff. I don't know, we used it to clean the grill. Okay, so what is it? Purple junk. Well, that really doesn't help people, right? So I want you to think about it in another situation. You know, if you get bit by a snake, chances are you're going to want to know what kind of snake you got bit by, because there's going to be a different antivenom for coral snakes versus a rattlesnake versus a moccasin, right? And I don't know biology, right, by any means, or geology, whatever that falls under, right? I don't know any of it, any of the ologies, right? But there's going to be a difference between treating something that affects your bloodstream versus something that, you know, a neurotoxin that affects your neurosystem, right? And you need to know that. It's going to save your life. So it's good to have product identification, because I need to know, you need to know, paramedics need to know. People that come in and they basically clean up, right? How do you properly clean up if there's a spill or leakage, right? So product identifier is something that usually goes in with the product name, right? The manufacturer. Who's the manufacturer of the substance, right? That's really good, because then you can always call the manufacturer too and say, hey, I need a little bit more information about this. You know, I mean, we're not placing blame on the manufacturer, right? But I know it's Purple Tiger. I know it's made by this person, this company. Got to call that company up, doctors can or whatever, and chances are, if they're already a registered company like that, things like poison control already have the information, because a lot of those companies have to submit that information as part of the MSDS to be included in it, right? So now you make yourself a little bit more aware, right? Who's your supplier? Might have supplier information, could have an address, could have things like emergency phone numbers with it as well, all in the product information, right? What's the physical data? Now, this might not be something that's important to you, and that's okay. I just know that it cleans grills. I just know that it makes that monitor shiny once I get done. I notice that it takes off the glare of the monitor once I clean it off, right? I notice that it takes dust out of the machine once I'm done with it, right? That's what I know. But what I might need to know is a little bit more about the physical data itself, and that's the information that's also included there, because it is important in an emergency situation to have additional information about the chemical compound. Right, because we talk about things like, let's take another, it's not really a substance, well, I mean, I guess it is a substance, but how I react to fires is a lot different between a grease fire and electrical fire, between a chemical fire and an electrical fire, right? Depleting oxygen versus putting a powder versus putting something that's non-toxic versus something that extinguishes the oxygen, which also kills the people in the room, right? So your reaction to a fire is going to be different based on what it is. So you have to know what type of fire it is, and you have to know what type of fire extinguisher to use, and likewise you have to know what the chemical is that you're using, because the reaction is going to be different, right? So what is the hazardous ingredients? What are the, the chemicals that are the makeup of it, if you will? So it could be hazardous ingredients, right? Is it explosive? I don't know, Zach, I don't know about you. I know you've done some traveling as well. I've done some road traveling and or just around town. Right, propane. Oh, here we go. Propane. We got to talk about propane. Propane trucks going down the road, and the first thing you see is a little flammable symbol in the back, right? Mm-hmm. Or it's an 18-wheeler that one of the things that they do is they work for a shipping company, and not every 18-wheeler, if you will, is going to be, or the rig, the cab is going to be hooked up to the same trailer, right? So what do they have? They have multiple flipped, like little flip boards, right? Today, we're carrying sailboat fuel, which means we're empty, right? We're carrying air. Mm-hmm. Nothing in there. I don't have to worry about it, right? But tomorrow we could be carrying propane. Tomorrow, the day after that, we could be carrying oil. Day after that, we could be carrying milk. Now, I know milk's a little bit different.
More
it's
coffee.
specialized, right? More coffee. There we go.
Coffee.
So you understand, we have to be aware of that. So is it a fire hazard? Is it an explosive hazard, right? Is it a caustic corrosion hazard? Is it something that if I spill on the floor, I'll come back and the floor will be gone? Right? Yeah, it might not be molecular acid like in the Aliens movies, but again, you do have to be aware too. What is the reactivity, right? And is that information there too? All right? Is it unstable? Does it have an instability in it? Toxicology, right? What are the health effects? A burning of the skin, a rash, right? Blinding, Do you have to get to the eye wash immediately? Don't induce vomiting. And I'm not trying to be gross here. Just trying to be serious in the fact that there are some things that you have to know. What are the preventative measures, or what are the appropriate handling measures? What are the first aid measures in order to treat something if you come in contact with this stuff? How do we contain the stuff? How do we clean it up? And more importantly, how do we dispose of it, right? Because, again, it's about the environment as well. So all of this is important, right? And these are some of the things that you will find in the material safety data sheet. Now, understand again, today, SDS is what it's called. If you're out there researching it and want some a little bit more information. All right, so that is a lot of it, I should say, about the MSDS. Next thing we have to talk about is what they talk about: temperature, humidity, level awareness, and proper ventilation. All right. It's environmental controls. All right. When we talk about environmental controls, we are not talking about the EPA. Well, I guess we could be in some situation, but not here, right? What we're talking about, think about our server closets. All right. Now, that's one of the things that you want to keep in mind, too. If we're in our server closets, right, what is the temperature of the server closet? You need to make sure that the relative humidity in the server closet is somewhere between 65 and 70%. Why? Well, because the higher the humidity, the more moisture we have in the air. The more moisture we have in the air, the more tendency we have for condensation. The more condensation we have in a system, the more likely we are for an electrical fire, or an electrical short circuit, right? Condensation, water, right? The opposite side of the spectrum is anything less than 60 to 65% humidity. We have dry air, right? We've talked about dry air. Think about the winter months. The dry air leads to a static charge generation. Static charge generation leads to electrostatic discharge, which destroys your components. Mm-hmm. So you have to have humidity level awareness, and this is why a lot of your climate control systems that you have in areas where they have a lot of computer equipment will have readouts that let you know what is the relative humidity. All right. Now, if you're at a tech bench where you're doing a lot of tech work, you might have that. If you have a dedicated area, right? You've mentioned clean room a few times, throughout the 902 series. There's
right.
Zach. They have temperature control systems in the clean rooms. They also have environmental monitoring systems that you can see and maybe even adjust. Right? If you're talking about dry air and too dry of air, they might have a humidifier in there. If you're talking too much humidity, like we had in certain areas where I used to do commercial painting, we'd have a dehumidifier. We had to put a dehu right in the middle of the room to suck all the water in, just so the paint would dry. Yes, right. Sir. Right. So you can see that that's not something that you just find inside of a server closet, but when you have hundreds of thousands of dollars of electrical equipment, or even $1,000 of electrical equipment, it is important. All right, so humidity level awareness is important. Temperature is the other thing too, because remember, thermal temperature management, right? Your thermal management is one of the most important things that you can do, because it's also one of the most detrimental things that can happen to a computer, right? That's why we have system fans. That's why we have heat sinks. That's why we have our cooling systems, right? So you have to make sure that the ambient temperature in the room stays colder too. A lot of times colder the better, right? Sometimes even so cold that you can't stand and have to wear sweaters, even better as well. Right?
I've experienced that.
Most, yeah. So we'll give you an example there, Zach. You know, one of the things I do is I like to jog at lunchtime, right? So one of the things I do, the first thing I do to cool down is I go into the server closet.
Right.
Why? Server closet is 68 to 69 degrees, and it stays that way.
That's right.
Right? The cooler, the better. When we talk about cool, you want to make sure that your systems stay cool. So you have to make sure that the temperature control is there.
Right.
Proper ventilation is important too. All right, and proper ventilation is also making sure that we're, vacating any, moisture, making sure that, again, we've got a good balance, right? It's the same thing. Think about it on a smaller scale too. When you talk about, like, for instance, your cases, your towers, right? We have a pull-push system. Yeah, pull-push system, right? And what I mean by that is on the ATX motherboards, the ATX form factor, we pull air in to the system, heat rises, and then we exhaust it out the back. And we have to have the right ratio to make sure that we're maintaining and the cooling system keeps everything cool. Well, that's why you need ventilation. You need ventilation in your server closets because you need that circulation. It is important. The other thing that you need good circulation for is things like airborne particles, right? And that's something that they also call out as a protection from airborne particles. They talk about things like enclosures. All right, enclosures as well as air filters and masks. Now, be careful with this because airborne particles, they don't call this out. And let me just double check on this. No, they don't call this out, but you really should have these too, and those are air ionizers. All right, and let me tell you why. Okay, most climate control systems, a lot of them, not saying most, a lot of them have filters, air filters. Well, here's the problem with the air filters. The air filters collect dust, and if people forget to service them, what happens to the dust that collects on them? It gets so heavy, it makes its way back into the same location that you're trying to pull it out of, right? Which is why proper ventilation is important, but ventilation doesn't happen when the filters get clogged. Another thing that happens with the filters too, when they get dirty, is they're really prone to mold and mildew. Again, that in itself can become an environmental hazard, right? That's why air ionizers are very, very good for things like climate control systems. And the reason I say that is because I used to call shenanigans on air ionizers until I kind of learned what they were doing. So air ionizers, what are they doing? Well, positive ions, all right, and I am not your science teacher here. Bill Nye, eat your heart out, right? I am not your science teacher here. You go listen to brilliant minds like Neil deGrasse and all of them, that they can help you out with this. But from what I understand, positive ions are where our dust particles come from, right? That's essentially what it is. And what an air ionizer does is it forces negative ions into the room. Positive and negatives attract. And what it does is it doesn't prevent dustborne particles, but what it does is when the positive and negatives attract, it makes those positive ions, those dustborne particles, so heavy they fall to the ground. And then they can be cleaned with traditional methods, right? Mm-hmm. Claws, brooms, if you will, electronic vacuums, right? Make sure the electronic vacuums, you don't want to use just the 1.5 horse shop vac, right? Too much static charge will lead to static charge generation, right. Electrostatic discharge. It's not something we want to do. So vacuums are good too. And they call it out just generically vacuums, but use the right vacuum. Use an electronics vacuum that doesn't have a static charge. The motor doesn't produce ESD, electrostatic discharge, right? Masks are for you more than anything, all right? So yes, you can use mask. And here, let me tell you why mask is important, because I'm going to use mask with the next topic that we have to talk about, dust and debris. All right, dust and debris gets in systems. That's just the way it is. You cannot, it's not a matter of if, right? I was talking to our director of production, right? And he's an engineer, he's a technical engineer. And he says, you know, he's like talking about hardware failure. And he goes, I'm an engineer, so it's not a matter of if it's gonna fail, it's just a matter of when, right? A great statement, because that's true. And that's true with everything in computing today, let alone some of the video production equipment that we have behind the scenes. Not a matter of if, it's a matter of when. So the same thing goes with dust. It's not a matter of if you're going to get dust in a system. It's just a matter of how long it's going to take, right? When are you going to get dust in a system? Well, I want you to think about what that dust does to a fan. I have seen dust seize an industrial ceiling fan. Seize it tight. Why? Well, because it accumulates. Well, think about you going in there and blowing that thing off, maybe with some a compressor, if you will, or if you're talking about your computers, or blowing it with some compressed air, right? Great things. But what are you turning around and doing?
Breathing it back in.
Breathing that stuff right back into your system, right? So that's why masks are also important. Now you might say, well, oh, Wes, that's hooey, right? Now this isn't something for the exam, but I want you to know one of the things that I'll do is I'll take a fan, even if it's a desktop fan, and not a desktop fan, I mean literally a desktop mounted fan, not a desktop fan. They'd be like, okay, well just take your fan out. A people fan, that's right, great way to put it, Zach. And I'll actually put that at the end of the tech bench and I'll turn it on high, and when I do, I stand to the side and I use compressed air, and as it blows the dust up in the air, it sends it out of my area, right? Even worse, or even, well, not worse, even better than that, if you're using compressed air to take dust out of a system, I actually take it outside, right? As many components as I can. You can't just take a 200-pound server off the rack and take it outside potentially, but blow that stuff away from your face, and if you have to, wear a mask. Wear some kind of respirator, right? It's not stuff that you want to get in your lungs and want rolling around your lungs, right? So you also have to keep that in mind too. Now, they talk about power surges, brownouts, and blackouts. A power surge, a spike in electricity, right? Temporary spike in electricity, which means there's more voltage in the line that should be there, right? That can ruin circuitry. Remember, our circuitry works on direct current. It doesn't do good with frequency variations, which is why it doesn't run off of alternating current, right? We have bridge rectifiers, right? And the rectifier essentially does kind of like a conversion. And what it does is it takes alternating current and it changes it into direct current, and it feeds it the power to our computer circuitry. Well, when you talk about plugging basically a power supply into an alternating current, there's still alternating current going into that power supply, and a fluctuation, if you will, a frequency variation in the power could cause some kind of damage to the system. That's why we want to understand what a power surge is. Brownouts are temporary low power events that happen, right? A brownout, sometimes the only way you know a brownout, and I don't know if you've seen this, and I know you've lived in Florida for a while, Zach, so I know you've seen it. The only time sometimes you even know that a brownout happens is when the lights flicker, right? Because lights are very sensitive to electrical current changes, right? And if they kind of dim a little bit, right, that's usually when you can see a brownout, because it's temporary low voltage happening, if you will, event. Versus a blackout, we know what a blackout's out. Blackouts is just electrical event is gone, right? That's good, exactly. Lights out, I love it. Yes, lights on, lights out, right? So we have to worry about situations like that, right? We have to protect our systems from these frequency variations and lights out conditions, like Zach, to coin a phrase there from Zach, right? And that's where battery backups come in, and surge suppressors. However, keep in mind that a surge suppressor is really only as good as the one you pay for, because it's really more like a fuse. Surge suppressor receives enough of, I think it's cold clamping voltage, joules I think it is, but the cold clamping voltage, it receives enough voltage and it trips whatever the fuse or the breaker switch is in it. However, I will tell you that if lightning hits it, and lightning goes down the current, and it hits that surge suppressor, lightning does what it wants. It's going to find the path of least resistance. It could jump, right? So understand those are only as good as the money that you invest in them, and understand that there's not really a lot that can stop things like lightning outside of the line suppressors, if you will, where they'll actually pop a complete circuit within the inside of the building itself, rather than what the computer's connected to. Battery backups, right? These are called uninterruptible power supplies, right? And you got a couple different types that I want to make mention of, and I know we're running up on time on this one. We got a couple of different types of battery backups. First of all, understand what a battery backup is, and then we're going to talk about what it's used for and what it's not used for. All right, so a battery backup, an uninterruptible power supply. There's an online and an offline battery power supply, or an uninterruptible power supply. They're calling it battery backup. That's more generic. It's called a UPS, and that's usually what we see when we buy them. All right, so an offline UPS, uninterruptible power supply, what does that do? Well, it means you plug your devices into it, and once we have a blackout, the lights out situation again, all right, that means it comes on and it provides power to your systems. That's offline. Why is it called offline? It's also called a standby as well, because it isn't providing power to your systems until there's the lack of the power from the AC outlet, right? That's why it's offline or standby. Then you have an online power supply. And an online power supply is one that is always supplying power to your systems, whether you have power in that AC outlet or not, right? So if I have everything plugged into that online UPS, uninterruptible power supply, and we still have power to the building, guess what? I'm still getting the power from the batteries. Now, why would I use one over the other? All right. Either way, whichever one you pick, this is why I want to say understand what a UPS is, and then now let's understand what it's good, what you use it for, what you don't use it for, and the choices that you have, why you would make a choice over one or the other. All right. What don't you use a UPS for? To provide power to your systems until the power is restored. That's not what it's for. It's never what a UPS is for. A UPS is used for to provide your systems with just enough time to perform a graceful shutdown, rather than a critical kernel power failure because you have a blackout, lights out, like Zach said, and your computers are in the middle of a write to the hard drive and you have data corruption and you can't recover from that. So usually what you do is you have your systems. What you'll see is, and definitely when you have UPSs stacked, a UPS connected to a UPS, and they start going one at a time, all of your systems are triggered to shut themselves down in succession, in sequence, within a certain amount of time, right? Your UPS might only give you a half hour at best, sometimes only a half hour, right? And you'll start hearing the alarms, and you can hear them, they're loud in some of the UPSs. You hear the alarms start triggering, it's letting you know those batteries are draining. And they each, your systems shut down one by one. Now, the online UPS versus the offline or standby UPS, why would you buy one or the other? Here's the consideration, all right? Offline or standby UPSs are typically found inside of home environments, and they're usually a little bit cheaper, a lot bit cheaper. Battery life, all right? Because you're not supplying power from your battery until the AC current is lost, the batteries last longer. Batteries are expensive, so they last longer because they're only online when the power is lost. All right. However, here's where they lose some functionality that your online UPS gives. They don't give line conditioning. All right. Now let me talk about why you would, the online UPS, and I'll mention line conditioning in the fact that that's what an online UPS does. Okay. Online UPS. Remember, we said that it provides power at all times from the batteries, whether you have power or not, whether there's a blackout or not on your systems. So what that means for us is that I get line conditioning. Why? Since the power is coming from a good direct current, clean direct current from the batteries at all times, I don't care about blackouts, I don't care about brownouts, I don't care about surges. Why? Because none of that surge that's coming off the AC line is going directly into my systems at all, because I'm getting the power from the batteries. And the batteries are always a nice, clean, even, direct current. I get line conditioning. And that's great. No frequency variations. Got to be something's bad. All right? Well, something that is bad is they're expensive. Why you typically find them inside of enterprise-level environments.
Right.
And the other thing is because you're always supplying juice from the battery, what do you think that does to the battery's lifespan?
Gotta replace them once in a while.
You got it. Yes, sir. You hit the nail on the head there, Zach. The battery's life is usually a lot less than what the standbys are. All right, so a couple of differences. Like I said, they just call them battery backups. But understand, it isn't to wait till your power comes back up. It's just to perform graceful shutdowns. Now, in this episode, we've been talking a lot about environmental impact and controls. The last thing I want to mention, probably what it should have been one of the first things I should have mentioned, is every bit of this is going to have to be in compliance with local government regulations. Now, that's all they call out here.
That's right.
That's all they call out here on the exam objectives. But understand you have federal regulations, you have state regulations, and your local government regulations, and all of them need to be adhered to, right? Not just what CompTIA is saying here. So make sure that from a business standpoint, right, from a non-exam standpoint, that you are checking with those regulations, and then make sure that if you do, you might not even have the decision, but be aware of them so that you maybe can inform your company, or that you are aware of them just in general so that you fall into compliance with the, the environmental controls and the impact that you could have on your local community, again, national level, state level, local level as well. Keep in mind, keep yourselves protected.
Awesome job as usual, Wes. Environmental impact and controls, CompTIA A+ 902. There's a whole bunch of video in this series. Make sure you watch them all. Wes does a wonderful job, and I know that you agree with me. And hey, thank you for watching IT Pro TV. Remember, a good IT Pro is always learning. I'm Zach Memis.
And I'm Wes Bryan.
And we'll see you very soon.
Thank you for watching IT Pro TV.